Hello, in the last videos we discussed about greedy algorithms and many problems. Let's discuss next one. Here is the question, read it and give it a try. A new circuit is developed which takes three inputs A, B and N. We have to return the maximum product of A XOR X and B XOR X, where X can be only less than 2 power N, and since the output can be very large, return it modulo some number, and the constraints are up to N up to 30. So A and B are up to 2 power 30 and N is less than or equal to 30. So given A and B, and we have to find the maximum product of X or X into big XOR X such that X will be less than or equal to less than 2 power N and A and B up to 1 in N. So let's take simple example where A and B are 0 or 1, binary 0 or 1. So if A is equal to 0 and B is equal to 1, what is the best possible option for X? So it will be surely 1, because if we take 0 0 and if we try to take 1 XOR with 1, it will be 1 and 1. So it is the maximum possible product that is possible for 0 and 0. And similarly for 1 1, if we take the value of X is equal to 0, then the product will be 1 into 1. This is also which is maximum. So if the bits both are at, if the both bits are equal, whether it is equal to 0 or 1, if they are 0, we can take X as 1. If it is 1, we can take X as 0, so that we can get the maximum possible product. So A XOR X is 1 and B XOR X is 1, and similarly it is 1 and it is 1. But what if A is 0 and B is 1, or A is 1 and B is 0? So in this case, if we try to take 0, then the value will be 0 for sure, because 0 XOR 0 is 0 and multiplied by any number is 0. And similarly, if we take 1, so we have 1, so the product will be 0. So here it is not possible to directly decide whether it is beneficial to take 0 or not. But it is not the case with this. So if it is 0 and 0, if we take 1, it will be maximum possible, and if they are 1, it is 0 to possible. So now the main question is, let's say we have different bits 0 and 1, and now which is better to take? It is 0, X is 0 or X equal to 1, which is better? So now let's discuss that, a small example. So this is the first bit and these both are equal. This is the second bit where those are not equal. So at this position we have taken X as 0, so it will be 0 at this position. And now coming to this bit, the main question is, here we have to decide X will be 0 or 1. So let's take it as 0, and when it is 1, so it is 0 in both cases here, MSB, and LSB is 0 and 1 here. So if the value is 0 1, now let's try to take XOR and multiply. So 1 0 XOR 0 1 will be 1 1, and 1 1 XOR 0 1 will be 1 0, and similarly product of these both will be 1 0 into 1 1. So if you observe, these both are same, but only they are exchanged, so they are swapped. Initially it is AB and next it is BA. So it means that they both are independent, and at any different positions which have different bits, we can take any 0 or 1, because as we have discussed here, if the bits are different, taking 0 or 1 is giving the same answer. So it is independent, or there is some dependency. So now let's come to the example. Initially 0 and 1. Let's assume that first one is 0, and let's assume in the next case that we have taken 1 initially. So now coming to first case, we assume that this is the first set bit. This is the first bit where both are different, and now let's assume that X is 0 here. And now coming to next one, even now the bits are different, 0 and 1. So now let's assume that there are again two cases, 0 1 and 1 1. And if you are taking 0 1, what will be the new product? It will be 0 0 XOR 0 1, which will be 0 1, and 1 1 XOR 0 1, which will be 1 0. And similarly, if we take 0 0, 0 0 XOR 0 0 will be 0, and 1 1 XOR 0 0 will be 1 1. So if we clearly look, this value is 0, and this is surely greater than 0. From this, we are able to understand that it is not independent, as we have discussed here, because only for the first bit it will be independent, and from the next bits it is not independent, because from this example we are sure that the result for this is 0, and for other it is not 0, it is 2. So we are sure that it is not independent. There is some other strategy. So let's take as example. So initially it is 0 1, and we have taken X equal to 1 initially, and now coming to next one, the two cases are 1 1 and 1 0. If we try to take product, it will be 1 1 into 0 0 and 1 0 into 0 1. So if we carefully observe, these both are equal, 1 1 into 0 1. These both are just swapped, and even 0 1 and 1 0 are equal, and these are also swapped. So we can take any possible value of X for the first bit where they are not equal, and now we can take the next one based on which is maximum, And even if we take 1, there is some possible configuration such that these both values will be equal, because here we have taken 0 and we have got 2 possible options, and here we have taken 1 and the both same possible options are here, but with a different configuration, because we achieved the same result with 1 1 and we have achieved the same result 1 1 into 0 0 with this as well 0 0. So we can, for the first one it is independent, we can take either 0 or 1 so that we can get a maximum possible answer in both possible cases. So now let's assume that, so for the first bit it is different, and for the first different bit it can be 0 or 1, and for the next one it is not blindly we can take 0 or 1. So let's discuss strategy for it. Initially a is equal to 0 and b is equal to 1, x is 0, and now coming to next one, 0 0 0 1, and let's assume that this bit is 0 and k, whether k is 0 or 1. Up to now we have taken test cases whether they are 0 and 1, and now let's just assume that it is k, whether it can be 0 or 1. So now let's multiply these both. So 0 0 XOR 0 k. So 0 0 XOR k is equal to k, because if k is equal to 0 the result will be 0, and if k is equal to 1 it means that 0 XOR 1 is equal to 1. So 0 0 XOR k is equal to k. So it will be simply 0 0 XOR 0 k will be 0 k, and similarly 1 XOR k will be k XOR k bar, because let's take k is equal to 1. If k is equal to 1 it is 1 XOR 1 it is 0, so it is k bar, and if we take 0 it is 1. So 1 XOR k is k bar and 0 XOR k is k. So the product will be 0k into 1k bar. And now let's just multiply. So 0k is simply k, because we can just ignore the MSB because it is 0. And now 1k bar is equal to 2 plus k bar, because it is 2 power 0 and it is 2 power 1. So 2 power 1 into 1 plus 2 power 0 into k bar, it will be simply k into 2 plus k bar. And now k into k bar is 0, because if k is equal to 0 it will be 0 into 1. If k is equal to 1 it will be 1 into 0. So for any k bar is 0, and now it will be 2k. So from this we are able to see that it is dependent on k. So we have just assumed some k and we have proved this, that it is not independent for the next different bits whether it is better to take 0 1. So from this we are sure that there will be some possible bit only for that the maximum value will be there. So if k is equal to 0 it is not maximum, only for 0 or 1 the result will be maximum. So now let's take a small example, and now the initial value, let's say a is equal to 10 and b is equal to 5 and the x value is 3, and now let's refactor the question. So we have to add this value to any of this and this, and we have to find the maximum possible product. So the first case is adding this to 10, it will be 10 plus 3 into 5, it will be 65. And in the second case let's add 3 to 5, it will be 10 into 3 plus 5, it will be 80. So which is the better possible option to get the maximum product? Surely it is better to add x to the lower value, because let's say we have added 3 here and 3 here. So what will be the new product? It will be this into this and this into this plus this into this, or this into this or plus this into this. So 10 into 5 is the same in both cases. So this factor is same in both. The factor that is different is 3 into 5 and 3 into 10. So it is surely better to add the x to the smaller value, because we can get larger product. So it is surely better to add x to the lower value. Even now it's the same. So let's say we are at some fourth bit from the MSB. We have computed the possible values of x for which the result is maximum for these 3 bits. And now we are at this position. We are at this. And now we are trying to decide whether the possible bit is 0 or 1. How can we do this? So we have A till now and B till now. So for the highest 3 bits, we found the maximum possible value of x such that vertex maximum. So we have A and we have B, and we found the x that is possible for maximum product. So we can get A till now and B till now. It will be simply x or x and b or x, where A and B are only till the third bit. So we have A till now and B till now, and now we have two different bits 0 and 1 here. So it is better to get one for the less value of A till now. So what is the main idea? So we have discussed here that if we are trying to add something and we are trying to get product, it is surely better to add to the lower value. So similarly, let's assume that the present bit is 1. So when it is better and for which this should be added. So we have two values, A till now and B till now, and now we are trying to add one here or here. So which is better to add? So it will be better to add to get one for the less possible value of A and B, so that we can get the maximum possible product from this example. So let's take an example to understand it better. So we have A till now. So A till now, and this value is B till now, and the present value is 0 1. So we are assuming to take this is A and this is B. So let's assume that these both have different bits, because we have to we got the best optimal choice for both same cases. So we are discussing the different one. So let's assume that A has 0 and B has 1. And now let's assume that x is equal to 0. So if x is equal to 0, this value will be same, and 0 XOR 0 will be 0, because we are assuming that x is equal to 0, and now 0 XOR 0 will be 0. And similarly, B is same, and 1 XOR 0 is 1. So it is 1. So this whole value is A XOR x, and this whole value is B XOR x. So better when A till now is greater than B. So we discussed that it is better to get 1 here, because this is A till now and this is B till now, and it is better to add 1 here if this is more. Only then we will get the maximum product rate, because we discussed in this example, in this one, we have two possible values, and it is better to add to the less value so that we can get the maximum product. And even now it is better to get 1 here where it is the less possible value. So let's assume that this is A and this is B till now, and if B is less than this, then A is greater. So the possible product will be greater when 1 will be here. So we will get the highest one. If A is greater than B, we are making x such that B till now will get the value of 1, so that we can get the maximum possible product. So if A is greater than B, we are taking x equal to 0, because we assume that initially B has 1 here. So if A is greater than B, we are trying to get the maximum possible product, and it will be correct when B will have 1 here. So when B can have 1, when x is equal to 0, because it is 1, 1 or 0 will be 1. So if B bit is set and A is greater than B, it is better to take x equal to 0, because we can get 1 here. So B till now or is equal to present, because we are taking x equal to 0, and the new B till now will be up to this bit, because let's say we are at 4th index and we have many similar other bits to simulate, and we got A till now till this, and now we assume we got that we are taking 0 here from this. So the new A till now will be the whole till now. So we got 1 here, so this bit is going to be on, so it will be till now or is equal to 2 bar bit. So we are adding these bits for the next possible bits. So hope you understand this. So we have A till now and we have B till now, and we have 0 and 1, and now we are trying to get the maximum possible product. So let's assume that we are going to add x is equal to 0. So after assuming that x is equal to 0, 0 XOR 0 will be 0, and 1 XOR 1 will be 0. 1 XOR 0 will be 1. So these will be the new A till now and B till now, and it is optimal only when A is greater than B, so that we can get maximum possible product. So, but what if initially A and B have set bits in positions greater than n? Because we have started traversing from x is equal to n, n minus 1, because it is given that x should be less than 2 power n. So we started from x equal to n minus 1, because for all other bits x should be 0, because it can be less than 2 power n. So all other bits greater than or equal to n less than 30 should be 0. But what if we have A and B have set bits in positions greater than n? Then we can simply start from 30, and we can look till j greater than or equal to n. And if jth bit is set in I, we can set that bit in A till now as well. Let's check n is equal to 2 and A is equal to this. We will start traversing from this, because it can have only 2 bits, because n is equal to 2, so x can have only 2 bits. So we'll start traversing from this, but we have these 3 ones. So how to consider this? So x is equal to 0, x is equal to 0 for all these bits, because we can have only 2 bits, because n is equal to 2. So all these 3 are 0, and hence 0 XOR k will be k. So if these bits are set, we can take in A till now, so that we have considered all bits till n for both A and B till now, and we can start traversing from n for n minus 1, and we can get the maximum possible answer. Similarly, if B set is bit, if the jth bit is set in B till now, is equal to or 2 power j. So we are setting this bit in p till now as well. So we are inputting a, b and n. A till now and b till now are 0 because we are starting from 0, and we are traversing from MSB from 30 till n. And if this is set, we are setting this in a till now, and if the bit in b is set as well, we are adding in b as well. And now we are traversing from n minus 1 to 0 because we can have only n bits in x. And now we are finding what are the bits set here. So a bit is a and 2 power a. It means that ith bit is set if it is 1. And similarly, if b if the ith bit is set in b, b bit will be 1, else it will be 0. If these both bits are equal, it means that both are 0 or both are 1. So if both are 0, it is better to take 1 because we discussed in the first. And if these both are 1, it is better to take 0. So anyway, we are going to make this both set finally 1 because we are taking 1 here, and if these are 1 and we are taking finally 0 to get 1. So in any case, both a till now and b till now will get 1 in the MS in that bit, because if it is 0 we are taking 1 and we are getting 1 in the final bit, and if it is 1 and we are taking 0 then we can get 1 in the final bit. So if both are equal, in any cases we can get both as 1 in this bit. And now if the bits are not equal, so if a is greater than b, it is better to get 1 in the b till now. So we are adding this to b bit till now. So we are adding this bit to the b, and if a is less than b, it is better to add 1 to a. So in this way we are updating a and b as we are traversing the loop, and we are greedily we got that it is better to add the value to the less one. So if a is greater than b till now, we are making this one, and if b is greater than this, we are making this one 1. So similarly, finally we are returning answer a mod into b mod, and finally we are returning answer. So in this way we can find the answer. If you have any doubts, comment below. Subscribe for more updates. See you in the next video.